Okay, so in this video, I'm going to go over how to do titration calculations. So a titration is another method to calculate the quantity of something that you're studying in a solution. So if you have a solution and you do not know the concentration of something, you can use a titration to get that amount. So basically, what ends up happening is you will take your unknown solution, your unknown concentration, and pour it into some sort of glassware, so either a beaker or a flask, whatever is most convenient. And you will put some sort of indicator in there. That might be colorless or it might be black or blue, and basically what will happen is you'll set it up underneath a burette. So this is a way to deliver liquid and to slowly add that liquid and to know how much liquid you add exactly. And you will know the concentration of this. Okay, it's going to have something that's going to react that's in your solution. So you're going to slowly add it, and eventually what will happen is it'll change colors. That indicator that you put in the beginning will change colors somehow. And then that tells you to stop adding your solution, and you will read how much liquid you dispensed, and based on that, you're going to figure out how much of your analyte or whatever the thing is that you're studying, how much of that is in your unknown solution. We use this a lot with acid-base reactions, but we can use it for pretty much most types of reactions to figure out the concentration. So the titrant is a solution that you know the concentration, and usually that's going to be what's in the burette and being delivered to the unknown solution. The titrant is going to be added until you reach the end point. That's when the indicator changes colors. So the end point will be when the indicator changes colors. The equivalence point will be when the amount of hydrogen ions is equal to the amount of hydroxide. So when we're talking about acid-base reactions, you're going to add hydrogen ions to your hydroxide or vice versa, and you're going to keep doing that until they're equal. That equivalence point, when they're equal, like right after you add a little bit more of whatever the titrant is, the indicator changes colors. So the equivalence point is usually just before the end point. The pH is usually 0 if you're adding an acid to a base or vice versa, but not always. And you'll see cases like that when we get to acid-base unit, or when we get to that unit. All right, so here is a typical titration problem. So 50 milliliters of a 0.1 molar solution of hydrochloric acid is added to sodium hydroxide. It reaches the equivalence point at 14.5 milliliters. What is the concentration of sodium hydroxide? Okay, so whenever you have a problem, first thing you should do, what is it asking for? Well, what's the concentration of sodium hydroxide? So I want to know the concentration or the molarity. That's what I want to know. And I know that molarity is equal to the number of moles divided by the liters of solution. So now let's see what I do have, because in order to get what I want, I have to have these two things. Well, I know that I have 50 milliliters of my hydrochloric acid. I also know that the concentration of that is 0.1 moles per liter, and it was added to 14.5 milliliters of sodium hydroxide. So I have 14.5 milliliters of that. So I have the volume of my sodium hydroxide, but I don't have my number of moles. So if I want my molarity, I need to get my number of moles here. So this is relevant for the end of the problem. I'm going to come back to this number. So it's important, but it's not important for right now. So I need to figure out, can I figure out the number of moles of sodium hydroxide that I had in my solution? Well, if I have the amount of hydrochloric acid, I can go from one substance to another substance with the mole. So I need a balanced equation between hydrochloric acid and sodium hydroxide. All right, so that's going to make sodium chloride and water. Make sure you're balancing your charges and everything. Well, everything's a 1-to-1 ratio because it's balanced at this point. All right, so anytime that I want to go from one substance to a different substance, which I do, I need the moles of sodium hydroxide. I'm going to go through the mole. So I was given my volume of hydrochloric acid. I want to go to moles of sodium hydroxide. So if I want to go to a different substance, I have to get to moles of my acid. Do not start off with a molarity. A molarity is a conversion factor. What this means, this molarity, means that for every 0.10 moles of HCl I have 1 liter of solution. A molarity is a conversion factor. Do not start with a molarity. All right, so now we're going to go from 50 milliliters of HCl to moles of that. So I have a conversion factor between moles and liters, so I need to get to liters. Then I can use my conversion factor to go to moles. Then at that point, I can go to moles of a different substance. Liters will go on top, milliliters on the bottom. 1 liter is equal to 1,000 milliliters. Then I can go to moles of HCl. So now I'm going to use my molarity. I have 0.1 moles over 1 liter. And then I can go to moles of sodium hydroxide. Moles on top of moles, I use the coefficients, so it's 1 and 1. All right, so now I'll do the math. All right, so I should get 0.005 moles. So this is not my answer. It asks for a concentration, not the amount. So I'm going to use this to figure out my molarity. So molarity is equal to moles divided by liters. Well, I have this, so I need liters of solution. So 14.5 divided by 1,000 should give me 0.145 liters. So now I take this, my number of moles, and I divide it by my liters to get my molarity. So 0.005 divided by 0.0145. That'll give me my molarity. All right, so it's going to be 0.344 big M, or moles per liter. And then technically, 0.45 if I round it appropriately. All right, so let's take a look at another type of problem. All right, the concentration of sodium hydroxide is 0.5. If 20 milliliters is needed to titrate 35 milliliters of acid, what is the concentration of the acid? Assuming the ratio of acid to base is 1-to-1. So you don't know what the acid is. But it does tell you that it's a 1-to-1 ratio, so for every 1 mole of acid, you have 1 mole of base. All right, so you know that for this, you have sodium hydroxide, and you have an acid. You're looking for the concentration of the acid. So I want the molarity of the acid, and I know that molarity is equal to moles divided by liters. What else do I know about the acid? I have the 35 milliliters of acid, so that's going to be 35 divided by 1,000 will be 0.035 liters. and I'm converting it to liters because I need molarity, which has to be in liters. So I need my moles of acid. So let's see what else was given to me. For my sodium hydroxide, I know my molarity. I know that I have 20 milliliters to start with. So I'm going to go from my base here to moles of the acid. So I'm going to start off with 20 milliliters of the base. And I'm going to go to moles of the acid. So it's set up pretty much the same way. So now I'm going to go to liters of the base. Base. Then I can go to moles of the base. And then I can go to moles of my acid. So 1 liter is equal to 1,000 milliliters. I'm going to go to my moles of base. So moles and liters, I'm going to use my molarity. 0.5 moles is equal to 1 liter. And now I'm going to go to my moles of acid. And it told me that it's a 1-to-1 ratio. So I can just write 1-to-1 here. All right, so 20 divided by 1,000 times 0.5 is going to give me 0.01 moles. So I have 0.01 moles of my acid, so I need my molarity. So that's going to be 0.01 moles divided by 0.035 liters. And 2 sig figs, so 229 big M. All right, so anytime that we have a type of problem like this, see what it's asking for first. So if it's asking for molarity, you need 2 pieces of information for that. You need the moles of that thing and then the liters of that thing. If it is asking for your volume instead and it gives you a molarity, you can use your molarity as a conversion factor to go from moles of that substance to liters of that substance. So you need to be careful. Just make sure you're reading what they're asking for and think about what you need in order to get that thing.